Right. Hello, everybody. Let me start sharing my screen. If you can see my screen, say yes in the chat. If you cannot, say no. Today, we're going to be starting a new unit. Right. So, yes, very good. Okay. So today is going to be lesson 1 of functions and the coordinate plane. And this is the new unit, unit 4. This is lesson 4.1. And we finished the unit 3 review. So if you haven't turned in your homework on that, please do. I'm all caught up on grading the homework, so you should be able to see your grades in the past few homework assignments. All right. So for our class schedule, we're going to go over our homework questions from the Unit 3 review homework. We're going to go over the coordinate plane and domain and range, and then of course, we're going to have practice problems. All right, so let's begin with our first homework question. So everybody, please put in the chat your answer to your homework questions for this one. All right, let's see. Okay, so we have 98 over 17 to infinity with 98 included. Very good. Very good. So let's see how we do this. Can anybody help me on this? All right, who can walk us through how we're going to do this? All right, William. All right, very good, William. How are we going to do this? Unmute yourself and walk us through how to do this.
So we first multiply 7 to everything. So it'll be 3x plus 14x equals to 98. I mean is greater than or equal to 98.
Very good, very good.
Then 17x is greater than or equal to 98. And then x is greater than or equal to 98 17ths.
I could keep this week going, but I have to take my class, which is like an hour long. So I'll join you back. If I leave, that means my mother. So yeah, I'm gonna mute this. Peace.
All right. I'll see you later. Okay. So that's very good, William. So in interval notation, you can put this 98 over 17th, right? To infinity. All right, it's greater like that. Then if you graph it, it's very easy. It's like this. Okay. So then we have 98 over 17. And this is included, right? There's an arrow. All right, very good. Next question. Please put your answers in chat. All right. Let's see our answers. We have negative infinity to 1.5. Right? So Elaine says negative infinity to 3/2, same as 1.5. Very good. Then 6/4 to negative infinity. All right, Hugo. Negative infinity needs to go first because it's the lower number. All right, and William, very good. Okay. So let's look at this. So who else can help me with this? Let's find someone else this time. Okay, Kaylee, can you help us with this? How are you gonna do this?
So first you multiply 8 by 1 and 8 times 2, so that means you get rid of the parentheses.
Very good.
And then you subtract 8 from both sides so that it is equal to 16x is less than 24.
Okay.
And then you divide both sides by 16, which would either equal 3 halves, 1 and 1/2, or 1.5.
All right. Very good. Very good. So hopefully everybody understood. I got that. Okay. Great job. Then we graph it. You have 3/2 right here. Like that. Okay. Next question. All right. We have 4 answers. Okay, 3 answers. Negative 26 to negative 14. All right. Very good. So Kaylee and William agree on that answer. And then Elaine says negative 32 to negative 20. All right. So let's see which one is correct. All right. So how do we do this? Let's see. So what we need to do here is we need to first move the 1 to both sides, since we can solve a compound inequality like this by solving it all at once. All right, all 3 sides. Okay, so let's look at this. We move 1, all right, add 1 to all sides, get negative 4 less than x plus 2/6 is less than or equal to negative 2. All right, so then we multiply everything, right, by 6. So we get negative 24 is less than x plus 2 is less than or equal to negative 12. Okay, so then subtract 2 on both sides. Then you get negative 26 is less than x is less than or equal to negative 14. Okay, so I have to pay attention to this. right? So on this side, negative 24, negative 26 is not included, so regular parentheses. But on this side, negative 14 is included, so we use the regular bracket. And if you remember and inequalities, right, between 2 points, so if you look at this, the graph should be like this. All right, very good, very good. Let's do this next one. All right, so let's look at this. We have all real solutions, negative infinity to infinity, and then, okay, Aiden, you put the answer to the wrong problem. We're doing number 4. All right, let's do this. Who can help us with this? Who can help us with this? So let's see. All right, William.
So basically, the answer is any solution, because the absolute value of something is always positive, and a positive number over 7, over a positive number is always greater than a negative number, so x could basically be anything.
Very good, very good. So the absolute value is always greater than a negative. Right? Very good. So that means that the absolute value of x minus 4 has to be greater than negative 21 no matter what, because it's absolute value. Right? So then it can be any number. You plug any number in, negative or positive, then it's always greater than negative 21. Very good. So our last problem.
Do it.
What was that?
Hugo, that was me.
Okay, you can solve this problem for us?
Yeah.
All right, very good. Let's do it.
Okay. So first you have to simplify it by timesing both sides by 6. So you get absolute value 4x minus 1, minus 6, is greater than 54, I mean. And then if you add the 6 both sides, you get absolute value of 4x is greater than 60. And then, so right here it's an OR inequality. So I can simplify it to 4x is less than negative 60, or 4x is greater than 60, which simplifies to x is less than negative 15, or x is greater than 15. And yeah, and you solved it basically.
Right, very good. So we can see here, x is less than negative 15, or x is greater than 15. Very good. So, and we do this in interval notation, right?
Thanks.
Okay. Very good. Very good. All right. Actually, let's graph that. So this is negative 15. This is 15. Graph like this. All right. There are no questions on that, right? No questions. Let's see. So everybody else got the correct answer. Very good. Very good. Okay. Let's continue. So now we're going to talk about the coordinate plane. So how we're going to graph a point on the coordinate plane, right? So whose background noise is that? All right. Okay. Okay, so how do we graph the point on the coordinate plane? So see here, does anybody have any experience with a coordinate plane? Does anybody know the experience with coordinate plane?
I know this. Yeah, I do.
All right, very good. Yes, x goes first. That is correct. All right, so let's look at this. How we gonna graph something on here? So this, the horizontal one, is gonna be the x-axis. And the vertical one, of course, is going to be the y-axis. I'm sure you've all seen this in elementary school, or if you are in elementary school, right? This is quite easy, right? So this is what they teach you this in like 4th grade, 3rd grade, I don't know. But this is quite easy. So let's just review how to graph a point. So these x values are all the values on the x-axis, and they correspond with the y-axis. So, and to graph a point, or to graph a point anywhere, let's say here, all right, here, this point, let's name it P, is going to be X, actually, let's say AB, going to be P, A, B, all right, so this matches up with the X coordinate, A, and this matches up with the Y coordinate, B, all right, okay, like that, all right. So then, if you look at that, then we can denote this point as a B, right? So if I tell you to find what this point is, then you know that this is 2, 2, because the this one, the x coordinate is 2, and the y coordinate is also 2. So therefore, this is 2, 2. All right. So it's very easy to graph, okay, on a coordinate plane. So are there any questions on this? No questions? All right, very good. Now we are going to go over what we call the distance formula. All right, this is what we call the distance formula. All right, so the distance formula, okay, is how we find the distance, right? So it helps us find the distance between 2 points on the coordinate graph. It's the distance between 2 points on the coordinate plane. All right, so if we had AB, let's say we have P x1, y1, and Q x2, y2. Then we can find the distance between them. And this distance formula is going to be using the Pythagorean theorem. And so who can tell me what the Pythagorean theorem is? All right, so we're going to write that in the little corner so we don't forget that. All right, so who can tell me what the Pythagorean theorem is? Hopefully someone knows. All right, does anybody know what the Pythagorean theorem is? All right, Zebo. Very good. What is
So,
the Pythagorean theorem?
like a right triangle, its legs, the length of the legs, like one of them is A, one of them is B. A squared plus B squared equals C squared, and C is the length of the hypotenuse.
Very good. Very good. Okay. So let's just put that in the corner. In a right triangle, the legs, right? In the right triangle, hold on, my pen is malfunctioning. Okay, so this is not straight. Something else. Off. Okay. Just keep it at that. Right. So in a right triangle, the legs, let's say this is A, this is B, right? And the hypotenuse, the long side is C. All right, and the Pythagorean theorem says that if A, B, C, well, this triangle is a right triangle, then A squared plus B squared is equal to C squared. That is the Pythagorean theorem. Right, let me draw this triangle a bit better. It's making me mad. Okay, what is this? I'm malfunctioning again. Somehow it just wants to. I'm drawing a straight line here. It's just very bumpy. All right, so let's draw the right angle. Okay, so let's A, this B, and this C. All right, very good. So now we see that we have the Pythagorean theorem. So now what is our distance formula? All right, so the distance formula that is just going to be the square root. And so write this down, that's very important, of x2 minus x1 squared plus y2 minus y1 squared. Right, so that is our distance formula. Does anybody know how we're going to prove this? Does anybody know how we can prove this using the Pythagorean theorem? All right, so we have 2 raised hands. Okay, are those still for this question or for the previous question? Or did you just forget to lower them? Oh, okay, so I'll just explain it real quick because this one is kind of hard to prove for at this level. All right, so let's look at this. If we have P x1 y1 and we have Q x2 y2, we have that, then we're gonna have to find the distance of the 2 points, right? So how are we gonna do that? If you actually look at this, you can make a right triangle like this. Make a right triangle like this, and the distance or the segment PQ is going to be the distance, but it's also the hypotenuse. It's also the hypotenuse of our right triangle here. So let me make this a little bit clearer. Like this. Right, and this is Q. All right, so what we need to do is we just need to find the legs, the distance of the legs, and that's easy because they're horizontal and vertical, so we can just easily find that. So this will be y2 minus y1, or in this case, y1 minus y2 because so let's change that. It's not good. Okay, let's change P and Q. Sorry about that. And so P is down here. Q is up here. And you can see that the length of the vertical leg is just going to be y2 minus y1. And then the length of the horizontal leg is just going to be x2 minus x1, right? Pretty self-explanatory. And then using the Pythagorean theorem, because from the Pythagorean theorem, we know that c is equal to square root of a squared plus b squared. Then if you know that a and b are x2 minus x1 and y2 minus y1 respectively, then we can plug that into the Pythagorean theorem. Therefore, we get x2 minus x1 squared plus y2 minus y1 squared. The square of that is going to be c, or the distance. All right. Are there any questions on this? So any questions? If you do have any questions, please say so now. No questions? All right, so that was a sort of proof of the distance formula, right? We know why it works, right? So it's very important. If we don't know why it works, then you can't really manipulate it. You can't understand how we use it, right? So it's very important that we know how this works. All right. So now what we need to do is we need to find the midpoint formula, right? We need to find the midpoint formula because that is the second formula that we are going to learn today. Okay, so right now, since you just saw me how to prove with this coordinate plane, it's actually, once you think about it, it's quite easy, right? So let's the midpoint formula is basically we have P and Q here. All right, and we form a segment like this, connect the two dots. We take the midpoint of it. So therefore, these two segments are congruent. Take the midpoint, and then how do we find the coordinates of the midpoint? What we're trying to find is the coordinates of the midpoint. So that is what the formula, the midpoint formula is all about. So before I prove this and tell you the formula, I want you guys to try and figure it out. All right. So brainstorm ideas on what is the midpoint formula. So everybody brainstorms ideas. So right, so I'll give you some time. Think about how we're going to do the midpoint formula. All right, so I'll give you like 1 minute to think about it. right, so now that we're back, let's think more about our midpoint formula. All right, so let's look at this. Our midpoint formula, what we need to do, right? So we need to find the middle of all of these coordinates. All right, so what you can really do is you can form a rectangle. You can form a rectangle like this. Actually, draw a rectangle like that. Right? Okay. Let's do this. Draw the other diagonal. All right, by geometric proof, since you know that these two are congruent, these two diagonals are congruent with the rectangle, then you know this. Right? By geometric proof, these are vertical angles. And by geometric proof, you know that these two triangles are congruent. Right? So then you can find this. Right? You can find this. Okay, so you see that the midpoint is actually that it's in the middle of the sides of the rectangle, right? So look at this. Let's make another one. Make it easier to see here. Make another rectangle like this. All right. So if you look at this, then the midpoint is actually in the middle of this, right? So let me tell you the formula, and then you understand why it's in the middle, okay? So if you look at this, then the midpoint formula, right? The midpoint formula. Pretty self-explanatory. It's going to be x1 plus x2 over 2 and y1 plus y2 over 2. All right, so in correspondence with all of these coordinates. And so the midpoint is basically in the middle of the sides, right? So basically the coordinates of the midpoint is basically half of x1 plus x2, and then the y coordinate is basically y1 plus y2 because it's in the middle. This is the hypotenuse, and then the midpoint is going to be in the middle of the hypotenuse, like that, right? So hopefully everybody understood that. That's quite a simple proof. Right. And Ethan also knows it. Very good. Oh, the 1 and the 2. The 1 and the 2 is just it's just subscript. Right? It doesn't really matter because it's just different types of x, let's just say, right? So x1 and then x2, those are two different types of x coordinates. It's too lazy to make different variables, I guess. But that's how we're going to do the subscript. I don't even know why subscript, but I mean, if you use a formula with so many variables, you're gonna run out of variables. So just do x1, x2, x3. I don't know, but basically that's the formula. So let's move on to domain and range. All right, so the domain and range of a function, right? The domain and range. Does anybody know what the domain and range is? All right. We have William. All right, very good. How are we gonna do this? All right, so what is domain and range, William?
I think a range is from one number is basically from the wait, I forgot. I think it's supposed to be from one point to another, like what's in between one point to another, and then the domain is its starting point. I'm not sure. No.
Oh, that's a good guess, but it is incorrect. Does anybody else know it? It's actually a much
The range,
yes.
the range is the range of exponents, I think.
What?
The range is the range of exponents. No, that's a domain, I think, right? Yeah. No, wait. No, yeah, like wait, no, sorry, no, nothing. I said nothing. I was thinking of polynomials. Sorry.
All right, so let's look at this.
Can I say what it is?
What?
Like, can I say what it is?
All right, very good. Who was that? Zero.
Dibbo.
All right, very good. Zero.
So, like,
How do you do this?
domain is all the x values of like a thing, I guess, and then a range is all the y values.
Very good. Excellent. So the domain is all the x values, and the range is all the y values. All right, so let's do a little example. Do a little example to help you understand how we do this. All right, so let's do this. All right, so if you look at this, all right, we have 1, 2, 3, 4, 5, 6. All right, so let's see. Let's say we have a function like this. Very weird function, right? Very weird function. But its function all the same. All right, so actually let's make it like that. All right. Okay. How do we do this? Yeah, that. All right. So let's find the domain and range. Let's find the domain and range of this. So how are we gonna find the domain and range? All right, let's see. Who can help us with this? How about William? All right. William, can you help us with this? Find the domain and range.
Wait, find it.
And you use interval notation, so use interval notation. Quite easy.
The domain and range.
Yes. So the domain is all the x values. How do you denote that using interval notation? The smallest x to the largest x, right? So what's
smallest x? So it is -1 to 5.
very good. -1 to
And
5 is 5 included.
Mhm.
Are you sure?
Wait, no, not 5 included, and with -1 included.
Very good.
And then the And then the range is -2 to 4, with -2 and 4 included.
Very good, very good. All right, so that's how we denote the range and the domain, right? Using interval notation. So now let's go on to functions. A function is basically a correspondence between the domain and range. That's a very simple definition. You'll learn more complicated definitions later in Algebra 2 or something. But basically, it's very easy. It's a function is basically just a correspondence between the domain and the range. All right. So the domain here, and the range, we have A, we have B, C, and D. And say A corresponds with D, and B corresponds with C. All right? So when you combine A and D, then you get a point. A, D. That's a point on on the graph of the function. Right? So basically this function is 2 points. Okay, so but there are special rules regarding functions. For example, one special rule is that one x value cannot correspond to more than one y value, right? So you cannot have a like this, right? You cannot have a corresponding to d and c, right? However, multiple x values can correspond to one y value, like that. So it is possible that, let's say, it is possible that we have, say, let's make this 3. Let's do this example. B, C, D, E, F. So C corresponds to F. It is possible that, let's say, and B and A correspond to D. Say no E here, or let's make this E. All right. It is very possible that A and B can both correspond to D. All right, so does everybody understand the restrictions regarding the functions? All right, comments or all right, very good. Okay, so look at this, functions, right? We can also use special ways to detect if it is a function. So what we call these the line tests, right? So this is not very important, but this is quite cool. So how do we detect if this graph is a function or not? By the restriction that one x value cannot correspond to more than one y value, meaning a vertical line cannot pass through the graph more than once. This would not be a function because one x value can correspond to multiple y values, right? So therefore it is not a function. However, this is a function, right? Because one x value only corresponds to one y value, all right? So that's basically it. So now let's go on to practice problems. Okay, we have a question. How can more than one x value correspond to one by y value, but you can't do the opposite? All right, so this very good question. You just can't. That's the answer. Because if you one x value corresponds to one y value, you learn later that then something is undefined, right? If one x value corresponds to more than one value, you'll learn later that if that happens, then something is undefined. All right, we'll talk more about that. We'll talk more about that, and when later in this unit, right?
Wait, what's unit 11?
What?
What's unit 11?
What?
What's unit 11 in this course?
Unit 11?
Yeah.
I have no idea. I said later this unit, unit 4.
Okay.
But unit 11 I'll worry about later because I don't know how long these units are gonna last. I might make new units or cut out units along the way.
Oh.
Right, Gazebo? Oh, you know why. Okay, that's very good. Why is it? Let's see if you're correct on why is it. But meanwhile, everybody else do the problem. Okay, why is it that one x value can only correspond to one y value? All right. I'll give everybody a few more minutes to do this problem.
Oh, frick.
All right. Square root of 40. Okay, very good. Square root of 40. Let's look at this. So find the distance between 2 points. So if you look at this, what we need to really do is just subtract the x values and the y values. So it's going to be the square root of this. It's going to be 4 minus 2 squared plus 9 minus 3 squared. It's going to be equal to 4 plus 36, which is equal to the square root of 40, which is going to be equal to 2, like that. But this is the simplified version. We won't learn about radicals until some other, like unit 6 or 7. So do not worry about simplifying the radicals yet. Do not worry about simplifying the radicals. All right. So just leave it at the square root of 40. All right. The square root of 40 can be simplified further, but right now we don't know how to. All right. So let's do this. All right. We're running out of time, so let me just walk you through this one. Actually, you know what? This one is actually not that hard. We just need to utilize the formula. Just plug it into the formula. So this one I'll leave as like a challenge question in the homework. And let's do these. These are important. So let's find the domain of fx. And right now, let's just find someone to help us with this. All right. So okay. Let's see. William, can you help us with this? William, you're good at this kind of stuff.
Wait, F parentheses X.
Yeah,
Does
that's
that
good.
mean
Actually, let me explain that in the function. So basically, a function basically. So this example is a function. F is the function name. It can be S. It can be S of X. It can be G of X, T of X. It can be anything, but usually we use F of X, and then G of X, and then H of X. All right, X is the input. Basically, the domain. The domain you can think of as the input. And the output is the range. So we put in an x, and the output is x minus 5. We put in 2, the output is 2 minus 5, which is negative 3. So basically, f of 2 is negative 3, if you look at it that way. So now, with this in mind, what is the domain of x to the 4? This isn't that hard if you think about it. The domain is naturally negative infinity to infinity if there are no restrictions. Are there any restrictions in this case?
yeah, I think so.
There's actually not restrictions. There are no restrictions.
Yeah, because even if x is negative, a negative number
Oh.
like to the 4th is always positive. So
Oh yeah.
It doesn't matter if it's negative or positive. The restrictions is undefined. If you can plug something into this and you get undefined, that's a restriction. There are no restrictions in this one. Plug anything in and you get a real number. So therefore, no restrictions. What is our domain? Negative infinity to infinity.
To infinity.
All right. What about this one? What restrictions are there? All right, let's see. Hugo, you're raising your hand. Do you know what restrictions
on what?
on this one?
I think so. No, wait, let's see. If you plug in 2, you get square root of 0, which is undefined. So yeah, it is restrictions.
Not really. The square root of 0 is 0.
Oh yeah.
Because
No.
0 times 0 is 0. However, this means that a negative number is undefined. The square root of -1 is I, right? Imaginary number. Right? So we can have undefined in our function.
So x has to be positive. So basically from 1 to infinity. No, yeah.
Are you sure?
I
No,
think it's
0.
I think it's 2 to infinity.
You think it's 2 to infinity? So the restrictions are, these are the restrictions. X over 2 minus 1 must be greater than or equal to 0. Right? It must be greater than or equal to 0. Otherwise, the square root is undefined. Let's solve this. X is greater than or equal to 2. Right? So therefore, our domain is 2 to infinity. Very good. Whoever said that. Okay, very good. Good job, William, right? Very good. Alright. Alright, so who can help us with this one? This one. What are the restrictions on this one? Does anybody have any ideas? Let's see. Jenny, do you have any ideas on what is the domain of this one? All right. How about Kaylee? What would make this undefined? Dividing by 0, right? Dividing by 0. So 3x plus 5 cannot be equal to 0. Those are the restrictions. Therefore, x cannot be equal to -5 over 3. With this in mind, what is the domain? William, can you help us with this? With this in mind, x cannot be equal to -5 over 3. What is the domain?
Wait, the domain. Wait, in interval notation.
Yeah.
Okay, then it has to be negative infinity and to -5 without including to -5/3, which doesn't include -5/3, and then it can also be -5/3 to infinity without including -5/3.
Very good. So basically, we're just doing negative infinity to infinity, but without including 5/3. Right? Very good. Those are the restrictions. All right, so that's about it for today. Thank you for listening. All right, and I'll post the homework very soon. Okay, great job. Thank you for listening today. Bye.
Bye. Thank you.
Bye. Thank you.